Hello students, I am Assistant Professor Karan Kumar Das, come back again for you. And on today, I will give the lecture about the oxalic acid. Oxalic acid, which is very common organic acid in the laboratory. So first, what is the IUPAC name of the oxalic acid? The IUPAC name of the oxalic acid is the ethanidioic acid. What is the IUPAC name of the oxalic acid? Ethanidioic acid. Okay, it is the IUPAC name of the oxalic acid. If the question will come in place of the oxalic acid, suppose the question will ask what is the laboratory preparation method of the ethanidioic acid, then you will write the laboratory method preparation of the oxalic acid. Don't be get confused. Okay. Next, the method of preparation. There are the two kinds of the methods of preparation. One is the industrial method and second one is the laboratory method. First, I am discussing about the industrial method of the preparation of the oxalic acid. See, in industry, basically, oxalic acid is prepared by heating the sodium formate at 400 degrees Celsius temperature. In the first step, sodium formate is heated at 400 degrees Celsius temperature and it is converted to the sodium oxalate along with the hydrogen gas. In the next step, sodium oxalate is dissolved in the water and treated with the soda lime, that means the calcium hydroxide. Okay, and in this step, by treating with the calcium hydroxide, it gives a precipitation of the calcium oxalate along with sodium hydroxide. Now, the solution makes the filtration, and after the filtration, the filtrate should be treated with the calculated quantity of the dilute sulfuric acid, and ultimately the final desired product, oxalic acid along with the precipitation of the calcium sulfate will be obtainable. And now the calcium sulfate has been separated because it is also precipitate, and now the oxalic acid is get crystallized in dihydrated crystals or dihydrated molecule, okay, in the form of the COOH2 along with double hydrogen molecule. Okay, so this is the total method of the preparation. Hopefully you can see it. Total method of the preparation of the industrially oxalic acid. In the first step, sodium formate is heated at the 400 degrees Celsius and sodium oxalate is obtainable, and in the next step, sodium oxalate is dissolved in the water and treated with the soda lime, that means the calcium hydroxide, and a precipitate of the calcium oxalate is obtained, and in the next step, the solution is filtered, and after the filtration, the filtrate is treated with the calculated quantity of the dilute sulfuric acid, and the precipitation of the calcium sulfate along with the crystal of the oxalic acid is obtained. Okay, and the calcium sulfate is separated out and the crystals of the dihydrated oxalic acid is obtained in form of the COOH2 along with 2H2. It is the industrial method of the preparation of the oxalic acid. If the question will come, write down the industrial method of preparation of the oxalic acid or ethanidioic acid, you will write this method. Next, I am discussing about the laboratory method of the preparation of the oxalic acid. In laboratory, the oxalic acid is prepared either from the sucrose or molasses along with the concentrated nitric acid, and the method is totally depends on the oxidation. Here, the sucrose or molasses are oxidized by the concentrated nitric acid, and vanadium pentoxide is present here as the catalyst. So what is the method for the laboratory preparation of the ethanidioic acid or oxalic acid? Here the oxidation of the molasses or sucrose has been done by the concentrated nitric acid along with presence of the catalyst vanadium pentoxide. Okay, this is the method of the preparation in laboratory. It is the method of the preparation of the laboratory of the oxalic acid. Clear? Next, I will discuss about the physical properties of the oxalic acid. See, when oxalic acid crystallized from water, it is basically colorless, prismatic along with dehydrated molecules. Okay, already I have discussed you when in the industrial method of the preparation of the oxalic acid, it is obtained as the dehydrated molecule. So when the crystals are obtained from the water, it is the colorless, prismatic and dehydrated molecules. Next, the dehydrated molecules of the oxalic acid that are melts more or less 101.5 to 101.6 degrees Celsius, but the anhydrous acid, those acid where the water molecule is not present, that is anhydrous acid of the oxalic acid molecule, that anhydrous acid will be melted at the 189.5 degree to 189.6 degrees Celsius. Next one, the hydrated acid becomes anhydrated if it is heated up to 150 degrees Celsius. Okay, and most important, remember one thing, it is one active poison. Okay, it is one active poison, and this is poisonous for the central nervous system along with both the kidney. Okay, it is very poisonous for the central nervous system, that is the CNS, along with the kidney. Okay, it is the physical properties of the oxalic acid or ethanic diuretic acid. Okay, next I am discussing about the chemical properties of the oxalic acid. First one, formation of the mono and di derivatives. See, oxalic acid, one of the strong organic acid. Okay, it is one strong organic acid. Within the organic acid, it is a strong acid. Okay, due to that reason, it forms two series of the salts, esters, acid halides and amides. Two series. See here I have given the example. Here disodium oxalate, which is a salt formed by the oxalic acid. Diethyl oxalate, it is one ester formed by oxalic acid. Oxyl chloride, it is one acid halide formed by oxalic acid. And oxamide, it is one amide formed by oxalic acid. And all are the di series. Okay, see here. Okay, salt, ester, acid halide and amide. Okay, and all are the di series. Next, what will happen when oxalic acid is heated? See, if oxalic acid is heated more or less 150 degree Celsius temperature, then it is converted to the formic acid along with carbon dioxide. When oxalic acid is heated at 150 degree Celsius temperature, then it is converted to the formic acid along with carbon dioxide. Okay, see here, when oxalic acid is heated 150 degree Celsius temperature, it is converted to formic acid and carbon dioxide. Next, I am discussing a very important reaction in the laboratory. Many times this method is used, the action with glycerol of the oxalic acid. Basically, the reaction of the glycerol with the oxalic acid happening in the two types of the reaction. First reaction, when oxalic acid reacts with the glycerol more or less 100 to 110 degrees Celsius temperature, then it is converted to the formic acid. Okay, but if the reaction happening on 260 degrees Celsius temperature, then within the oxalic acid and glycerol at 260 degrees Celsius temperature, then the reaction end product will be allyl alcohol. Okay, so what is the two products? Reaction between the glycerol and oxalic acid. If the reaction will happening at 100 to 110 degrees Celsius temperature, then the end product is the formic acid. But the reaction between the oxalic acid and the glycerol is happening on 260 degrees Celsius temperature, then the end product will be allyl alcohol. This method is used in laboratory for the preparation of the formic acid and allyl alcohol. Okay, very important reaction, remember it. It is the reaction of the glycerol with oxalic acid. If the reaction will happening at 100 to 110 degree Celsius temperature, then formic acid will be obtained, but the reaction will happen at 260 degree Celsius temperature, then the end product will be allyl alcohol. Clear? Next, the action of oxalic acid with concentrated sulfuric acid. If oxalic acid is heated with concentrated sulfuric acid, then carbon dioxide and carbon monoxide along with water is produced. What will happen? If oxalic acid is heated with concentrated sulfuric acid, then carbon dioxide, carbon monoxide along with water is produced. Last one, if oxalic acid will oxidize by the acidic potassium permanganate solution, what will happen? Here carbon dioxide and water is produced. If the oxalic acid is oxidized with the acidic potassium permanganate solution, then carbon dioxide along with water is produced. That's all the chemical properties of the oxalic acid. Now, last thing that I will discuss, that is the use of the oxalic acid. See, the most important use of the oxalic acid, the removing of the ink stain and for the bleaching of the head straws. Why? Because it has a very important property. It can reduce the ferric salt, which color is the brown, to almost colorless ferrous salt. Due to that reason, in these two purposes, oxalic acid can be used. Okay, if the question will come, why oxalic acid or ethanoic acid we can use for the removing of the ink stain or for the bleaching of the head straw? Your answer will be, it can reduce the ferric oxide, which color is the brown, to almost colorless ferrous oxide. Okay. Next, it can be used as a mordant in the dye and as well as in the redox titration and in the manufacture of the metal polish and ink. And the very important, already I have discussed with you, action with glycerol. In the laboratory, it is used for the preparation of the allyl alcohol and formic acid. That's all about the oxalic acid or ethanoic acid. Before completion, I am requesting you, those who can take the screenshot, they can take the screenshot of this note. Thank you. Thank you everyone. Now, if you feel any doubt, you can contact with me in my WhatsApp number 9804915527 or email me at karankumardas103@gmail.com. Hope you all can understand this video. So, I am requesting you, be sincere on your study and as well as on your health also and the health of your family also, because today we are passing through a challenging situation. Hope you know everyone for the COVID-19. So I am requesting you everyone, be careful on your health and maintain the social distance and washing your hands time to time by alcohol based hand sanitizer or soap. Be careful, be safe, stay at home and sincere on your study. Thank you. Good day.